Okay, so in this video I'm going to try and show you some of the basics of the CRP5 for navigation purposes. So there are lots of things you can use for navigation. You can use an electronic navigation device such as this. This is the Sporty E6B. There's an aluminium version, which they like in the States. There's Transair do one. This is the TPS1 with its instruction book, circular slide rule and wind velocity side. I'm not going to use that one. The one I'm going to use is probably the most commonly used one, which is the CRP5. And again, there's an instruction book with it. So the CRP5 is essentially a circular slide rule on one side and a wind velocity calculator on the other side. Just a few things about it. In terms of marking it, to mark it you would either want a nice sharp pencil and an eraser, or better still, just a non-permanent mark with a fine point that you can use to mark it. And when you clean it, just soap and water. Don't use alcohol or ethanol, or you will rub numbers off. As you can see, I've managed to rub some off just up here. So let's deal with this side first, because this is actually the simplest side. There is a wind slide which has two sides, you'll notice. It has a low wind speed side with an L, low speeds, and a crosswind and headwind calculator at the bottom, centimetre ruler down one side, and down the other side a nautical miles ruler for a half mil 1 in 500,000 nautical mile chart. And on the other side, which you won't be using for the PPL, it's the high wind side marked with an H, higher speeds, a slightly higher crosswind and headwind calculator. The nautical miles ruler is for a 1 in quarter mil map, and on the other side there's an inches ruler. So most of the PPL stuff, in fact all of your PPL stuff, will be done using the low wind speed side. So it goes back in the slide. Make sure you've put it in the right way up, not the wrong way up, or your calculations will be completely haywire. You'll notice some of the other things on it. It says true heading at the top. There's port drift up to 50 degrees, starboard drift out to the right, again up to 50 degrees. We'll come on to those a bit later on when we do the triangle of velocities calculation. What about the other side? I'll just take the slide out just to make it simpler. The other side looks confusing when you first look at it, especially if you've got it upside down, but it's not actually as bad as it seems. This is just a circular slide rule, and it's got quite a lot on it, so at first glance it can be a bit daunting. There are a couple of things to note. Simple ones at the bottom, Celsius and Fahrenheit, so you can do direct temperature conversions. Remember, there is a formula if you want to memorize the formula with the plus or minus 32 times 9 over 5 or 5 over 9, depending on which way you're going. But why bother? You can just read it off straight here. So 0 degrees Celsius is 32 Fahrenheit. 40 minus 40 Celsius minus 40 Fahrenheit, and so on. I should just point out that simple calculations like ratios, multiplication, division, you can do it on here, but why bother? Get yourself one of these. Very cheap, very simple computer calculator. And in fact, this is what you need for the exam. You cannot use anything that can be programmable or scientific for the exam. So it has to be a simple calculator. And for simple mathematical equations, why would you bother doing it on a CRP5? Just use the calculator. What can you do on here? Well, there's lots of things written on it. You'll see that on the outside you've got distances, nautical miles, statute miles, kilometers, meters, yards, and you've got volumes, imperial gallons, US gallons, and you've got two specific gravity calculators. One of them, specific gravity with pounds, the other one, specific gravity in kilograms. So distances, volumes, and so on the outside, and on the inside is time, and it does actually say minutes. That's the bit that moves. So there's minutes are always on the inside, volumes, distances, and weights are all on the outside. There are three smaller windows on the inside for altitude, airspeed and density altitude, which we'll come on to when we do some more calculations. The thing I should point out is that you have an instant reckoner for minutes to hours, quite important in aviation, which may sound quite simple, but if you want to know how much, let's say for argument's sake, 180 minutes is, you look at 1/8, 180, and underneath it says 3. So 180 minutes is 3 hours. So that one's easy, you can do that in your head. But what happens if you wanted to know something that isn't an easy calculation in your head? You can just read it off the scale. The point about the circular slide rule, which you'll realise when you start doing calculations, is there's no decimal point. So you need to have some idea of what the number is going to be so that you can factor in the decimal point. So for example, 180 minutes, there's no 180 on here, there's only 1/8. So that could be 1.8 minutes, could be 18 minutes, 180 minutes, 1,800 minutes, could be any multiple of 1 and 8. So you need to have an idea of what's going to be the answer that you expect. We'll come on to some of the conversions in a minute because it is quite useful for that. The other thing to note is that if you look at the two blue numbers, see there's a 10 on the outside and a 10 on the inside. If you set it up like that, you've set up an isoatmosphere. So if you go and look at the altitude window, a pressure altitude of 0, which is sea level, is 5, 10, 15, plus 15 degrees. Same in the airspeed window. Yeah. 0, hopefully you can see that, is plus 15 degrees. 0, 5, 10, 15. Hopefully that's clear. So you can set up the isoatmosphere on it. Don't worry too much about the others at the moment. Things like compression corrections and Mach, you shouldn't really need those if you're using this for the PPL. If your PA28 airspeed is calculated as a factor of the Mach number, you need to speak to an engineer. There's something wrong with your aeroplane. Some of the other things you can do are other conversions. Now, they'll tell you when you're starting learning the theory for PPL that you need to know some corrections and some factors in your head, and that's quite true. So let's just have a look at a few of them. I think I've got some written out. So here are the common ones. Sorry, I'm actually wearing this camera on my head, so every time I move my head the camera moves. Apologies for that. Let's see how this does. So 1 nautical mile, 1.15 statute miles, 1.852 kilometres, 6,076 feet. So you will have to learn those, but I'll just give you one quick trick for the kilometres. Nautical miles to kilometres, on a calculator, it's 1 point, and then all the numbers in a row, 1.852. So that one's an easy one. What about all these other ones? Are you really going to remember them in your head? You may do, but for the exam you may not. But you can use the CRP to actually do it for you. Because if you look carefully where it says kilometres, metres and litres, there's an arrow. Yards, there's an arrow. Pounds, there's an arrow. US and imperial gallons, again, 2 small arrows. Feet, there's an arrow. Nautical miles and so on. So you can set it up to do the conversion for you. So if you put the 10, which is a 1, under metres, yes, and then go around to feet, you've got to find it first. You've got to be able to read English, which is a bit of a problem. So there's feet, there's the little arrow. If I line the two of them up, hopefully you can see that it says 31, 32, almost 33. You could actually call it 33. Remember 1 metre, 3.28 feet. So if you remember where the decimal point goes, you can say that that is 3.3. So 1 metre is 3.3 feet. You can do it for some of the others as well. Statute miles to kilometres if you like. So let's go back and find statute miles. There it is. Put the 1 under statute miles. There it is, lined up. Hopefully you can see the 10 is under the little arrow. Statute miles. And now come around and find kilometres. You can go the long way around if you choose. Stick it under there. It's pretty much bang on 16, 1.6. So hopefully you can see that you can get the conversions just by using the CRP5. So don't worry if you haven't remembered it for the exam. You can use it, the CRP5, to give it to you. Same for imperial gallons and US gallons. How many imperial gallons in a US gallon? But if you put the 1, remember the 1 is 10 on this because there's no decimal point. Put that under imperial gallons and go and look at US gallons. That comes out to 12. So it's very, very unlikely that 1 imperial gallon is going to be 12 US gallons. So the decimal point is going to be in between the 1 and the 2. So 1 imperial gallon, 1.2 US gallons. And that's pretty much what the calculation says. The same for kilograms to pounds. So find kilograms, put the 1 under the kilogram mark. There it is, 1 under the kilogram. Come around to the pounds. Look at that, 22. Again, 1 kilogram isn't going to be 22 pounds, but 1 kilogram is going to be 2.2 pounds. So you can do the conversions quite easily. The other thing that you will have to convert is specific gravities using weights and volumes. Remember that 1 litre of water weighs 1 kilogram, so that gives it a specific gravity of 1. Now notice the specific gravity scale doesn't have 1 because most people can do the 1 times table in their head. If you can't, find something else to be doing. You'll see on this one again, it doesn't go up to 1. It has anything below 1. This one says pounds, this one says kilograms. So aviation fuel has a specific gravity of 0.72 to 0.82, which means that it is lighter than water, which is why water sinks to the bottom of your fuel tank. It's why water sinks to the bottom of the fuel sampling tube. So if you want to know how much fuel weighs, the volume of the fuel times its specific gravity will give you the weight. And we'll come on and do some calculations using that at some point later on. So that's just an introduction to what it all means. Oh, I should point out there's one other thing to look at, which is the 60. 60 in the black triangle is quite an important one on the circular slide rule, because that is 60 minutes. And 60 minutes, you'll be pleased to know, is 1 hour. And a lot of calculations in aviation are done on the basis of an hour. So knots, nautical miles per hour. So if you put that under the 80, for example, what you're saying is that that's 80 knots, 80 nautical miles in 1 hour. So how long will it take me to do 40 nautical miles? Well, you just come around and look at the 40. Remember, distances are on the outside, times are on the inside. 40, 30 minutes. That one's an easy one to do. But what happens if you say I'm doing 80 knots, and how long will it take me to go 110 miles? Well, go to 110 and you'll see it's going to take you 1 hour, 80 minutes, 83 minutes. How much is that in hours? Remember, you can use the yellow one to convert minutes to hours. So that's going to be 1.22 hours or thereabouts. So that's what the 60 means, and we'll come back to that a little bit later on as well. So the next bit we'll do is triangular velocities in the next video.